Okay, the reason why we compute this is that we know this, we will show you this. So we will prove this theorem. So we will show that an integer has a multiplicative inverse if GCD A and M equals 1. So A has a multiplicative inverse modulo M if GCD equals 1. To prove this, we will use the previous fact that this fact. We know that for any number x and y, there exists coefficient a and b such that ax plus by equals GCD of x and y. Now, if GCD of x and y is 1, we will show that we can find the inverse. Okay? If GCD x and y is 1, we can find the inverse. How can we do that? So let me show you first. Okay, so what's your number? So let's continue with this example. Okay, we know that from your friend, we know that his number is 113 and 43, right? So the GCD of this is 1. So we know that there exists some number A times 113 plus some number B times 43 equals 1. Okay, and from his computation we know that A is 8. Okay, and B is what is that? Okay, so this is from what your friend did. Okay, now I want to find is that I want to find inverse of 43 modulo 113. I want to find this. How can I find that? Okay. So these two things are equal, right? So if I have two numbers which are equal and I modulo with the same number, I'll get the same thing. So this is our goal. I want to find this. Okay, so I can modulo the whole thing 113. So if I modulo the whole thing with 113, these guys go to 0 because 113 mod 113 is 0, right? So I get that minus 21 times 43 mod 113 equals 1 mod 113 because the first term 8 times 113 mod 113, this is 0. Okay, so now I know that this mod the same thing, right? So I can rewrite this to be minus 21 times 43 congruent to 1 mod 113. Okay, so what is minus 21 mod 113? 92, right? So I know that this is the same thing as 92 times 43 equals 1 mod 113. So 92 is our inverse. Okay, so this number. So we want to find the inverse modulo 113. You use extended GCD algorithm to find the GCD of 113 with your number, and then you get A and B. The coefficient B is actually the inverse that you are looking for. Okay, so let's do the calculation really quickly. See, so 92 is actually the inverse of 43. Okay, so in your sheet, in your exercise sheet, after you figure out the A and B, the value of B will be the inverse of the modulo 113 that we're looking for. Okay? So let me go over the proof really quickly. So this is gonna be if and only if proof. So it's gonna go both ways like this. Okay? But we prove only one way. We prove that if GCD is 1, there is a multiplicative inverse. Okay? I'm not gonna prove the other way around because we actually don't have time. Okay? So I'm gonna prove only in these directions. Okay. So suppose GCD of A and M equals 1. We know that there exists integers A and B. This is from the extended GCD algorithm that we've just shown. So there exists integer A and B such that A, this is A, right? So I should use something else. So there exists integer M and N. Oh, M is already there, sorry. P and Q. P is prime. A and M, so what else should I have? I don't want to use X. K and L. Okay? There are two integers K and L such that K times A plus L times M equals 1. Okay? So this is from the extended GCD algorithm that we have tried. Okay? So if you divide, if we can modulo the equation with M and get K times A plus L times M mod M. This is gonna be K times A mod M, right? Because L times N mod M is gonna be 0. Because this goes to 0. Okay. And then this equal to 1 mod M, or K times A equals 1 mod M. So K is the multiplicative inverse of A modulo M as required. Okay, so that's the proof that the multiplicative inverse exists. But if TC is not 1, you cannot have the multiplicative inverse. The other way around, I'm not going to prove it. Okay. You can read it here. So the proof that I showed you is this one. So this is the key thing that you should know from this section. Basically, if GCD is 1, you can find the multiplicative inverse. Okay, and you should be able to find the multiplicative inverse. Okay, so on this page, if you finally come up with B, so that would be the inverse of the number that you're looking for. Okay. All right. So let's have a. Let's have 3 minutes break, really quick, because I need to go at 3:30 because I have to go to the other class. But I need to tell you about one other thing. We need to work on an exercise on the back of this sheet.